solving quadratics. This is where the math starts to become fun. I'll just have a quick recap about factorising quadratics. We have a little quadratic here, x squared plus 6x plus 8, and we're looking for an a and a b such that x something or other a, x something or other b equals this, and a and b are numbers. And we showed earlier that plus 8 and plus 6 are the important numbers. ab equals 8, thank you, and a plus b equals 6. We solve this to find the unique a and b. So let's look at factor pairs of 8. We'll start off trying to solve this one. 8 and 1, well, don't add to 6. Minus 8, minus 1, very optimistic. Certainly don't add up to 6. 4 and 2, yes. Multiply to 8, add up to 6. 4 and 2 are our numbers, and we can say that x squared plus 6x plus 8 equals x plus 4, x plus 2. Brilliant. So that is a factorising, but that isn't solving, because this isn't an equation, this is just an expression. We need to get to this. This is now an equation. This equals 0, and this has solutions, 2 solutions for x that make this true, and we need to find them. And we use the method of factorising. So here we go. That's what we've got, this is what we know, and that's equal to 0, because the original equation was equal to 0. And now we use one of the great theories of mathematics. I love this one. If s and t s times t equals 0, then s equals 0 or t equals 0. If you can find 2 numbers that multiply together to give 0 and one of them isn't 0, send them to me and I will claim a prize. I'll share it with you. There aren't any. Either one of s and t have to be 0, which is brilliant, because look what we've got here, 2 numbers, or 2 brackets I should say, that add up to 0. So if this bracket times this bracket equals 0, then one of the brackets equals 0. X plus 4 equals 0, or x plus 2 equals 0. If x plus 4 equals 0, what does that tell us about x? It tells us that x is equal to minus 4. And if x plus 2 equals 0, well, you've got to sort of get it really, that x equals minus 2. One of these must be true, and there are 2 solutions therefore to this equation. Let's look at this one again in more detail. There is the factorisation, there is our assumption therefore that one of these brackets equals 0, and therefore these are the solutions, x equals minus 4 or x equals minus 2. Now interestingly, when we factorised, we look for an a and a b, but these are the inverse. X is equal to minus a or minus b. Very common mistake for people to factorise and then write down plus 4 and plus 2 as the 2 solutions. They're not, they are negative. Right. Of course that's never complete without a check. How do we check this? Well, this is the exciting bit really. We use x equals minus 4 and x equals minus 2 in this equation and show that it equals 0. So x equals minus 4, that's our equation. X squared is 16. 6 times minus 4 is minus 24, and 8 is 8. 16 minus 24 plus 8 equals 0. Let's try the same with x equals, oh, I've got my 2 here, it should be minus 2. So x squared plus 6x plus 8, x squared is 4. You've still got minus 12, which is 2, minus 2 times 6, and you've got 8. So add this lot together and it equals 0. My bad, that should be minus 2. Let's have a look at an example. Here's the catchphrase, AB is the number, A and B the centre. Solve x squared plus 2x minus 15 equals 0. Well, we're looking for an A and a B, where AB equals the number minus 15, and A and B is equal to 2. So we're looking at factor pairs of 15, which are 15 and 1, where they don't add up to 2, 5 and 3. Now this is where it gets interesting. The difference between 5 and 3 is 2. Now, for minus 15, we need a positive and a negative number. So I think we can find that if we make 5 positive and 3 negative, they will multiply to minus 15, but when you add them together, you're going to get 2. And these are our numbers. So this is our solution. X squared plus 2x minus 15 is equal to x plus 5 minus, times x plus minus 3. So one of these has to be 0. So either x equals minus 5 to make this 0, or x equals minus 3 to make this 0. And notice that these are the opposite, or the inverse I suppose, of a and b. 5 and minus 3. The solutions are minus 5 and 3. Let's have a little check. I'll check the easy one. X equals 3. X squared plus 2x plus 10. X squared is 9. 2x is 6. Minus 15. That should be minus 15. My bad. Anyway, that's minus 15. And that equals 0. I'm going to do this again. I am going to do this again as a punishment for being useless. Let's have a look at an example. AB is the number, A and B the centre, our key phrase for factorising. Here's the equation, x squared plus 2x minus 15 equals 0. We're looking for an A and a B that satisfies this, and therefore A times B is equal to minus 15. The number A and B equals 2, the centre. We're looking then for factor pairs of 15, 15 and 1, nope, 5 and 3. Now, interesting thing about 5 and 3, the difference is 2. And you know to get a negative number, we need to multiply a positive by a negative. So the difference being 2 is going to make it possible to get A plus B to equal 2. If I take a positive 5 and a negative 3, they multiply together to minus 15. They add together to plus 2. That's our number. So here's our answer. X squared plus 2x minus 15 is equal to x plus 5, x minus 3. So far, well, we've done this before. But the solution to make this 0, we need x to be minus 5. Or to make this 0, we need x to be 3. So this is these are the two solutions to this equation. And obviously we're going to do a check. We're going to check the easy one. X equals 3, put that into the equation. X squared plus 2x plus 15. X squared is 9, 2x is 6. Minus 15 equals 0, which is exactly what we want. Thank you very much. A moment of joy. A moment of joy. So that is a very hard question, solving a quadratic. I hope that's made it a little bit easier. Still tricky, still nasty. If you like what you've seen, or if you haven't liked what you've seen, why not subscribe? If you're taking an exam soon, best of luck.